Look around you right now. The chair you're sitting on, the bottle of water on your desk, the packaging that arrived with your last online order, the keyboard under your fingers. Chances are, at least half of what you can see is made of plastic. In fact, the world now produces more than 400 million tons of plastic every single year, and the plastic industry is valued at over $600 billion. But here's the question almost nobody stops to ask. Where does all of it actually come from? The answer might surprise you. It starts not in a factory, but deep underground as crude oil. Today, we're going to follow that oil from the moment it's drilled out of the earth, all the way to the moment it becomes the plastic objects filling our daily lives. Welcome to the channel where we uncover the fascinating stories behind the things that shape our world. The story of plastic begins millions of years ago, long before humans existed. Over vast stretches of geological time, the remains of ancient plants and animals were buried under layers of rock and sediment, compressed under enormous pressure, and slowly transformed into crude oil. Today, that oil sits in underground reservoirs beneath the Earth's crust, and getting to it requires one of the most powerful industrial operations on the planet. Oil drilling involves sinking a wellbore deep into the earth using a massive drilling rig equipped with specialized rotating drill bits. Once the wellbore reaches the underground reservoir, the natural pressure within it forces the crude oil upward toward the surface. As that pressure gradually decreases over time, engineers use pumping systems and inject gases or fluids to keep the oil flowing. From the wellbore, the oil travels through pipelines to the oil refineries, sprawling industrial complexes where the real transformation begins. Crude oil on its own is a dense, dark liquid that contains thousands of different chemical compounds. It can't be used for anything directly. First, it has to be broken apart. This is done through a process called fractional distillation. At the refinery, crude oil is heated in a furnace to around 400 degrees Celsius or 752 degrees Fahrenheit. It vaporizes and is fed into the bottom of a tall tower called a fractionating column, sometimes over 30 meters high. Inside the column, temperature decreases from bottom to top. As the vapor rises, different compounds cool and condense at different heights depending on their boiling points. Heavier compounds like bitumen and fuel oil condense near the bottom. Lighter ones like gasoline and kerosene condense higher up. And near the very top, the lightest fractions of all, including ethane and propane, are collected as gases. But there is one fraction that is especially important for plastic production: naphtha. Naphtha is a pale yellow liquid made up of medium-weight hydrocarbons, and it is the primary raw material from which most of the world's plastic is built. Naphtha is useful, but its molecules are still too large and complex to become plastic. They need to be broken down further into smaller hydrocarbon molecules in a process called cracking. And this is where the chemistry becomes remarkable. In steam cracking, naphtha is mixed with steam and exposed to extremely high temperatures of around 800 degrees Celsius inside a cracking furnace. The intense heat breaks the large hydrocarbon molecules apart into much smaller, simpler molecules. The most important of these are ethylene and propylene. These tiny molecules are called monomers, which are the true building blocks of plastic. Other useful monomers like butadiene and benzene are also produced at this stage. These gases are then carefully separated and purified to an extremely high level of chemical purity, ready for the next transformation. Now comes the step that turns simple gases into one of the most versatile materials ever created. The process is called polymerization. Polymerization is the process of chemically linking thousands of monomer molecules together into long repeating chains called polymers. It is the core process in plastic manufacturing. There are two main ways this happens. In addition, polymerization, monomers like ethylene or propylene bond together directly, using catalysts to break their chemical double bonds and link them end to end. This is how polyethylene, polypropylene, and PVC are produced. Polyethylene is the most common plastic on Earth, found in bags, bottles, and packaging. In condensation polymerization, two different types of monomers react with each other and release a byproduct, usually water, as they bond. This method produces materials like nylon and polyester, plastics you'll find in everything from clothing to carpets. The result of either process is a raw polymer, which at this stage still isn't quite plastic as we know it. It comes out of the reactor as a powder, granule, or liquid, and must go through further processing before it's ready for use. The raw polymer is then compounded, meaning it's melted, mixed with additives, and then extruded through a machine that presses it out as thin strands, which are immediately cut into tiny pellets. These pellets are called Nurdles, and they are the universal currency of the plastic industry. These Nurdles are then packaged and shipped around the world to manufacturers who use them as their starting material. At the manufacturing facility, Nurdles are melted down again and shaped into finished products using several techniques like injection molding, extrusion, and blow molding. In injection molding, liquid plastic is injected at high pressure into a mold and cooled into a precise shape. This is how bottle caps, toys, and car parts are made. In extrusion, plastic is continuously pushed through a shaped opening to create long profiles like pipes, tubes, and sheets. In blow molding, a blob of molten plastic is inflated inside a mold like a balloon, producing hollow objects like bottles and containers. After shaping, the plastic is cooled and solidified to retain its desired form and properties. Plastic properties can be enhanced by mixing additives during or after the polymerization process. These additives give each plastic its specific character, color for appearance, UV resistance for outdoor durability, flame retardancy for safety, flexibility, etc. The same properties that make plastic so useful, its durability, its resistance to degradation, also make it one of the most pressing environmental challenges of our time. Between 1 and 2 million tons of plastic enter our oceans every year, affecting wildlife and ecosystems across the planet. Plastic production and disposal now account for around 5% of global greenhouse gas emissions. A particularly overlooked part of this problem is Nurdles themselves. Each year, an estimated 445,000 tons of Nurdles enter the environment worldwide, spilling from production sites, trucks, and shipping containers, washing into waterways, and ultimately reaching the ocean. And recycling, despite decades of public awareness campaigns, remains deeply limited, with only around 8.5% of plastic actually being recycled. Global plastic use is projected to reach 1.1 billion metric tons by 2050, up from just 2 million tons in the 1950s. The world is working towards solutions, from bioplastics derived from corn and plant sugars to international treaties aimed at capping plastic production, but no binding global agreement has yet been reached. From ancient organisms buried under rock to oil rigs on the open sea, to the naphtha that feeds a cracking furnace, to the tiny nurdle that arrives at a factory floor and becomes the bottle in your hand, plastic's journey from crude oil to finished product is one of the most extraordinary industrial transformations ever devised. It is a material of remarkable ingenuity, and it is a challenge of equal scale. Understanding where it comes from is the first step to understanding what we do with it next. Thank you for watching. Don't forget to like, subscribe, and stay with us as we continue exploring the surprising stories hidden inside the simple things that shape our world.